Let's look at the next 5 questions for the day. So the first one is again pretty straightforward. We have to expand the first 2 brackets, so that will be x squared plus 2x plus 5x plus 10. So that will be x squared plus 7x plus 10. Now we have to multiply that with 2x minus 1. So if I start multiplying and get x squared times 2x, which is 2x cubed, 7x times that will be 14x squared, 10x times that will be plus 20x. We multiply the next set of numbers, x squared times minus 1, so that will be minus x squared, 7x times that will be minus 7x, and then 10 times that, which would be minus 10. So if you follow that pattern, it would be easy for you to simplify. So your final answer would be 2x cubed, 14 take away 1, that's 13x squared, 20 take away 7, that should be 13x, and then finally minus 10. So that's our first question. Number 7 says, you're given 2 equations of lines. We need to find the gradient of the second line. Now, if you're ever finding the gradient of a line, or if you're asked to find the gradient of the line, the first thing that you need to do is you need to change, or you need to make y as the subject, so that you end up with y equals mx plus c, and whatever is the coefficient of x would be your gradient. So we've got 5x plus 2y minus 9 is equal to 0. So we're going to make y as the subject. So we're going to kick everything onto the other side except the y here. So minus 9, when it gets kicked to the other side, becomes plus 9. 5x, when it goes over, becomes minus. So we've now got 2y is minus 9 becomes plus 9. 5x becomes minus 5x. Last thing to make y as a subject would be to get rid of the coefficient 2. So divide 2, divide 2, divide 2. We'll be left with y equals 4.5 minus 5 over 2x. If you wish to, you can leave it as 5 over 2, or if you wish to, you can do that as 2.5, whichever you prefer. Now, the gradient would be the coefficient of x. So everything that is attached to x would be the gradient. So the gradient m would be minus 2. So final answer would be the gradient m is equal to minus 5 over 2. So many people tend to write the answer as minus 5 over 2x, which is incorrect. You might get marked down, maybe, you'll never know. So only the coefficient of x is your answer for the gradient. It's not the x term that is attached to it. Right, before we do this one, we'll also do one more question, which is finding the point of intersection of these 2 lines. So if you ever want to find the point of intersection between 2 lines, between 2 curves, a line and a quadratic, 2 quadratics, whichever, whenever you hear the word point of intersection, I want you to remember we are doing simultaneous equations. So we've got y equals 4x plus 3. And the other one is 5x plus 2y. So 5x plus 2y minus 9 is equal to 0. Let's make them into the pattern that we are most familiar with. So we'll keep 4x minus y equals minus 3. Basically, I've swapped between these 2 guys. And the next one would be 5x plus 2y equals 9. So we've got these 2 here. Now we're going to need a common number. So I'm going to get a 2 here. And if I have to do that, I'm going to have to multiply everything by 2. So this becomes 8, and that would become 6. And now all I have to do is just add them up together. So that would be 13x. This becomes 0, and that becomes 3. So I get x is equal to 3 over 13. So if x is equal to 3 over 13, I'm just hoping I haven't made any mistakes. Minus 3, minus 6, not y, I've got 2y. Yeah, looks okay. So I've got the x coordinate. Now what I'm going to do is I'm going to plug that in here so that I can get to my y coordinate. So y would be equal to 4 lots of 3 over 13 plus 3, which is 12 over 13 plus 3, and that would be 30, 39 plus 12, 12 plus 39 over 13, which is 49, 51. 51 over 3. So the point of intersection for these 2 points would be x coordinate 3 over 13, y coordinate 51 over 13, and that would be my point of intersection. So whenever you hear point of intersection, think simultaneous equations, and you can solve them to get to your answer. Next one, we've got 2 exponential expressions that are equal to each other. So the technique here is you need to make the base the same. So if you can get the same base, then you can form an equation with the powers as well. So 16, as we know, is equal to 4 squared. So 16 can be replaced with 4 squared, and 4 squared now gets to the power of x is equal to 4 to the power of 10 minus x. Now you remember laws of indices. Power of a power, you multiply them together. So now you have 4 to the power of 2x is equal to 4 to the power of 10 minus x. Because the bases are the same and the expressions are equal to each other, that means now you can argue that these 2 powers must be equal to each other as well. So now you have 2x is equal to 10 minus x, or now you have 3x is equal to 10. So x is equal to 10 over 3. So get the same base. Once you have the same base, equate the powers. Once you have the powers the same, you would be able to find the equation and then solve it. Last question is finding the area of this quadrilateral shape. First part is easy because we could do half of base times height. So my base here is 24x, height is 10x. So that will be 24 times 10, which is 240, half of 240, which would be 120x squared. So that part is easy. That wasn't bad. Now to find the area of this isosceles triangle, I guess we're gonna have to find the height, which goes exactly through the middle, and then use that somehow to get that. So if I focus just on this isosceles triangle, I'm going to need the base of that triangle, which is AC, and I'm going to need the height of the triangle. Let's call that as H. I can find AC. AC is not that bad because I can use Pythagoras theorem because I've got the base and the height, so I can work out the base AC quite easily. So AC would be equal to square root of 24x squared plus 10x squared. So if we do that, that should give us square root of 576x squared plus 100x squared, which is square root of 676, and then x would remain as x. So this was 676x squared, but you can square root the x, so it's 676x. 676x. Can we do anything with that? I wish I had a calculator with me. Okay, let's see. Oh, yeah. So we're going to see 676. Can I divide that with 4? Oh, I can. That's 169. So that means I can do... Oh, I think 676 is a perfect squared. No, that's good. So 676 is 26. Brilliant. So we know that is 26x. So if AC is 26x, then we know this height should be 13x and 13x, because in an isosceles triangle it splits exactly in half. So that means I should be able to find out what is the height. So height would be square root of, because here I've got my hypotenuse, which is 85, and I've got the other side. I should be able to find the third side, or the shorter side. So that would be 85x. You need to square the entire thing. Many people tend to do this. 85. They tend to square it, but they forget that this 85 also needs to be squared as well. So please don't do 85x squared. It is 85x the whole squared. And because it is a shorter side, we're doing subtraction. So that's 13x the whole squared. And let's see, what do we get? So we have 85 squared. Take away 13 squared, which is 7056. So we have square root of 7056x squared. I'm hoping 7056 is a perfect squared. 7056 is 84. So we've got the height, which is 84x. We've also got the base. So all we've got to do now is, again, half base times height for this one. So it's going to be half. Base is 26x. Base is not 13. Base is 26. Please don't mess that up. And then height would be 84x. So altogether, that would be 0.5 times 26 times 84, which is 1092. So the area of the bigger one is 1092, and the smaller one is smaller triangle 120 120x squared. So altogether the area of the shape would be 1092x squared plus 120x squared, which should equal 1092 plus 120 is 1212x squared. So that's that for today, and we will see you tomorrow with the next set of questions.